Hey, what up, pre-algebra? It's Mr. Mac in case you couldn't tell by the photo or where you're viewing this video from, but I hope digital learning treated you as well as it could last week. I miss seeing your faces in class and getting a chat with you and dive into the mathematics with you in person. But I feel pretty fortunate to be able to share with you at least this way. Please don't hesitate to continue to reach out via email. I have office hours Wednesday, 3:30 to 4:30. It'd be great to see you there. I saw someone pop in for a second and leave, but I'm here for you with whatever you need. So this week we're diving a little more into these functions. A little refresher, a function for each domain, there's exactly one range. So now instead of just saying is it a function or isn't, we're going to be saying what type of function is it. And we're going to start with proportional functions. So for this video, really what I'm going to do is this is coming after you do your Desmos activity, and I'm going to go through the Desmos with you, all right? So let's get after it. So as I look at this first question on your Desmos, is it proportional? So one thing you need to remember for proportional is the ratio of y to x is going to be the same for the whole thing. So here's our x, y values. And so it goes through the origin. Our y to x, we can't use that because there's infinite answers. But everything else, let's look right here. We got 5 halves. We got 10 fourths. We got 20 eighths. We got 35 14ths. So if I simplify here, I get 5 halves, divide these by 4. I get 5 halves, divide these by 7. I get 5 halves, which tells us, yes, this first representation is proportional. Y to x is the same. Let's check out this. We have the origin, that's good. And so right here, y to x, I got 4 to 1. Right here, I got 8 to 2, which is 4 to 1. Here I got 10 to 3, which is 10 to 3. Uh-oh, you might notice. We don't have the same ratio of y to x, therefore, this one is not proportional. My ratio changes. Guys, I know this is going to be quick. Pause, rewind, hit the bell, like and subscribe, share it with your grandma. But you do not need to go fast just one time. You can go back, rewind, watch it 3 times if you want to. I'm all about it. All right, so now we have a graph. We do not need to do ratio of y to x anymore. There's a little easier way. There's 2 criteria. Criteria 1, does it go through the origin? It has to be both these. The answer is yes. It goes through the origin right here. Next, is it a line? Like a straight line? The answer is yes. So this is proportional. And if we took a y to x, for example, let's just do it right here. Y to x there is 5 to 1. We go right here. Y to x is 10 to 2, which is 5 to 1. What we were doing before still holds true. Let's check it. This one looks a little different, guys. You might notice right here. So origin, does it go through the origin? So it's a straight line, right? Check. But you need both. So this one is not proportional. Let's take a look at this line. Y equals 6x minus 4. We've got even another representation of lines. We've worked with multiple representations all year. And what this is saying is, what we need to look for here is, does it go through the origin? And proportional relationships, whoopsie, 1 second. Proportional relationships, remember, they go through the origin, and they have the same ratio of y to x. They also are always in this. You'll see it as either one of these. K being the constant of proportionality, D being direct variation. Is it in this form? And you might notice there's that minus 4 right there. So this one, not. But here's another reason why. If you were graphing this, so when x is 0, to see if it goes through the origin, when x is 0, 6 times 0 is 0, that's gone. Y would be negative 4, which tells us our line starts right there and goes something like this. Again, not through the origin. That's just another way to think about it. How about this one? Keep doing that, guys. 1 sec. It's because I'm working on iPad and computer here. All right, here's another one. Does this do the y equals kx format where we have a constant of proportionality right there? Yes, it does. Right there. There's our constant of proportionality. Another way to think about it, when x is 0, y is 0, through the origin, yes, that one is proportional. So let's try to find that constant of proportionality. If we're looking at our y to x's anywhere here, okay, it's telling us that this has a constant of proportionality. We can use any of them. I'm going to choose 8 to 5. Another way you could do that is 1 3/5. I would take y equals 8/5 x. This is my personal favorite. Y to x is going to give me that constant right here, remember? Or you could, maybe if you did 8 divided by 5, you get 1.6x. I would take either one of these, but that's my fave. You know me, I like those fractions. I like those improper fractions. I'm all about it. Okay, same thing here. Let's look to get that y over x, or we've called it slope as well. This point right here is 2, 4, 6, 8. So these go by 2s, I just want to point out. 2, 4, 6, 8, 10. It goes through the origin, so that's cool. So this point right here, that point right there is 0.26. So if I go y to x from my constant of proportionality, I get 6 to 2 for a constant proportionality of 3. So that's going to give me the equation y equals 3x. Same idea here. If we have 0.216, my y to x is 16 to 2, or 8. That gives me the proportional equation y equals 8x. Here's another one. If I have 0.810, my y to x constant of proportionality would be 10 to 8. I like to simplify that to 5/4. So there's two good answers here. 5/4 x is my personal favorite, or some people might do 1.25x. It's the same thing. There's my fave. All right, so now we have another representation. Now it's in context. 14 apples for $28. So that's going to give us, did it again. I've been doing so well. Where are we at here, guys? Whoops. There it is. Okay. So 14 apples for $28 would be like ordered paired 1428, which tells us that each apple costs $2 for a proportional equation, y equals 2x. Okay, let's see how many miles per hour we drive in this situation. 330 miles in 5.5 hours. Okay, so 330 divided by 5.5. I'm gonna try to do this without a calculator, guys. How's that sound? I can divide these both by 5 and get 662 over 11, which would be a pretty big number. We can do it. I'm trying to decide if I want to. No, it's going to be a fraction. 1 sec. So let's just roll with that fraction. It'll be 60 and 2/11. You might end up getting something like 60.18 repeated. I'm cool with that. All right. So 60 and 2/11 miles per hour. Thanks for watching, guys. I appreciate you. I know you're trying your best, hopefully. Let's keep that in mind. Effort is greater than being right, okay? I just want you to go hard. You maybe have heard me say that. Effort is greater than being right. You can learn by messing stuff up. I do it all the time, all right? I want you to get after it hard, try your best, and then remember, office hours. Wednesday, 3:30. Hit me up. A Zoom link is on Classroom for you, all right? Miss you guys. Go hard.